Hello everyone, welcome to Altibase webcast and presentation. First of all, is anyone first time to listen to this? Just in case you don't know me, my name is Daniel Seo. I'm an education consultant in Altibase Corporation. Today we're going to talk about the topic called what is MVCC, okay, which basically means how Altibase HDB does concurrency control. Okay? Okay, it's a method that prevent the inconsistency, loss, and the changes while processing multiple transactions. Okay, so that's the definition of concurrency control. Okay, database is not a software for a single user, okay, which means the multiple users or multiple sessions access it and use it together. When that happens, the multiple users or the multiple sessions could access or modify the same record at the same time. Okay, so the database provides something called concurrency control to prevent such event. Okay, the concurrency control is a method that control multiple transactions. So it actually prevents um, any inconsistency or the loss that could be occurred while controlling multiple transactions. Okay, in order to do this, okay, the lock is needed. Um, and Altibase provides something called row level lock, which is the smallest object level lock provided on default. This lock actually allows transactions to not to affect each other and update the same data. Okay, we'll have a look at this lock in a moment. Okay, so when you look at the diagram, the three clients are accessing the table at the same time. Okay, then let's suppose that there's no concurrency control in a multiple users or multiple transaction environment. Okay, and we will never know which data is the right one. Therefore, finally, it will break the data integrity. This is why the concurrency control is so needed. Then let's have a look at what this means. Okay, so the concurrency means is allowing multiple users or sessions to access the same data at the same time. Okay, and whereas the consistency is restricting multiple users or sessions to access the same data at the same time. Okay, so the concurrency and consistency are opposite each other, and if they are drawing a diagram, it looks like this, as a following diagram. Okay, like this following diagram. So if we minimize the log usage to increase the concurrency, then we have to give up the consistency. Vice versa, if we use the log as many as we can to increase the data consistency, then the consistency got lower. Okay, therefore, the log is essential element to prevent multiple transactions accessing the same record at the same time. So we want to have a look at the log first. Okay, as you look at the diagram, the two transactions are modifying the same record. Okay, one is changing the price to 1 million, and the other one is changing the price to 2 million. Okay, if the log doesn't exist in this situation, then the consistency will break. Okay, so that's why we use the log to guarantee the consistency. So transaction 1 grants the log first, and transaction 2 waits for transaction 1 to release the log. Okay, so when a user wants to modify data by DML or DDL statements in database, so the corresponding data needs to get a log first. This is to prevent from other transactions or other users modifying the same record at the same time. Okay, the log can be given on each data or multiple data or entire table through transaction. The log is automatically given and released, and it also helps to avoid the conflicts among other transactions. Okay, so it prevents the modifying same data in multiple user environment. Okay, and the log is given when DDL and DML is executed. Okay, and so the purpose of log is to provide maximum consistency inside the transaction. And Altibase used two types of log, the table level log and the row level log. Okay, we're going to have a look at those types in a moment. Okay, so log helps to provide the data integrity in a system. Okay, The log can be obtained by various objects inside the database, and the size of those objects are also various. For example, the objects they can have log are such as database itself, the schema, table, and the row column, okay, and etc. And they are getting following orders as a diagram. Okay, as you look at the diagram, the most upper object, the database, is the biggest, and as we go down, the size gets smaller. Okay, the bigger the objects, it gets the higher level of lock. The smaller the object gets less level of lock. The big level of lock has low level of concurrency control, and the small level of lock has the high level of concurrency control. So that's the difference. For example, the table level lock deals with the entire table. So even though the other transaction is modifying the different record of same table, then the transaction has to wait because the lock is granted in the entire table. Whereas the smaller level of lock, such as row level lock, only deals with the record. Therefore, when the other transaction is modifying the different record of same table, because the lock is given as row, the transaction doesn't need to wait for the lock to be released. Okay, therefore the level of concurrency is different depending on the lock that object has. Okay, so when lowest level lock, the row level lock is granted, the high concurrency control is guaranteed. Okay. Altibase provides the row level lock, okay, the lowest level lock, and the table level lock, and the upper level lock to optimize the level of concurrency control. Okay, now let's have a look at the row level lock. Okay, as you can see, there are one type of row level lock, and there is X, the exclusive lock. The exclusive lock is given for DML. Okay, so user with the lock can select and update, and other transaction cannot do any of statements. Okay, the table level lock is the lock that is given to table only. Okay, the types of table level lock is in Altibase are shown as a diagram. Okay, so the shell lock is a user with the lock can select data, and other transaction can only select the data as well. And the exclusive lock is user with the lock can select and update, but other transaction cannot do any statements. Again, the intent shell lock is the user with this lock can select only once. Once the intent shell lock has to be obtained first, and the shell lock second. Okay, the intent exclusive lock is a user with the lock can select and update. Okay, once intent exclusive lock is obtained first, and the exclusive lock the second. Other transaction can also select and update different data from the same table. Okay, the share with intent exclusive lock. User with this lock can select, and once exclusive lock is obtained, then you can update as well. Okay, other transaction can only select, not update. Okay. Okay, then let's have a look at what types of lock is given in different situations. Firstly, when select statement is executed, okay, the intent shell lock is given to the table. And once the intent shell lock is given to the table, user can select the record, and the other transaction cannot execute any DDL on the table. Okay, same for DML statement. When DML such as insert, update, or delete is executed, then intent exclusive lock is given to the table, and the exclusive log is given to the record. Okay, so that the user can execute DML on the record, and the other transaction cannot execute any DML or DDL on a table. Okay, when DDL such as alter, create, or drop is executed on table, then firstly the intent exclusive log is given to the table space, and then exclusive log is given to the table. So the table space is not affected by others while modifying tables. Okay, now let's have a look at the types of conflicts. Okay, the concurrency controls is mainly divided into SVCC and MVCC. In single version concurrency control, the SVCC, the only one version of record exists. Therefore, when multiple users or multiple sessions access or modify the same record, the performance is remarkably reduced. However, the MVCC, which stands for multi-version concurrency control, is slightly different. Let's say when there's a modification in a single record, then the old version is remain and a new version of the image is created. And the modification is occurred on the new image, not on old image. Okay, let's take a closer look for both of them. Okay, SVCC, because a record is logged, when it's modified, the conflicts can occur between read and modifying operations. Thus, there's a high possibility of reduced performance in environments characterized by frequent transaction. Okay, so it means that because only one version exists, that's why the conflict is occurred. Okay, so there's a data obtained. So when a client A modifies record firstly, the exclusive log is granted. And now the client B wants to see the data. Okay, because the log is given, the client has to wait until client A finishes modification. Okay, once client A executes commit statement, now the client B can see the data, which is 20. Okay. Okay, so SVCC could cause performance reduction in complicated environments because only one version of data exists, meaning one transaction has to wait for other transaction to finish all the time if they are accessing the same data at the same time. Okay, the MVCC. When a record is modified, the log is granted and the new version of record is created. So conflicts do not occur between read and modifying operation. Okay, the good performance is guaranteed even in environments characterized by frequent transaction. Okay, let's see what we mean by that. MVCC does concurrency control with two versions. Okay, not just with one version. Okay, so the client A tries to modify the record. The original record and the exclusive log is given. Okay, and the old image remains and remains the same, and a new version is created. Okay, so when client B accesses the original record, it gets the value of 10. And okay, remember in SVCC, the other client has to wait, but in MVCC, the other client can access the data. Okay, so because the new image of record is committed, the original record is deleted by memory Asia, and only the new image of record is remain. And now the client B can access the new image of record, which is 20. Okay, but there's one thing I need to introduce is that MVCC is different when it is in this table or when it is in memory table, because memory and disk have different characteristics of data each other. So that's why they have to be handled differently as well. Now let's have a look at what those are. Okay, the Altibase. In memory table, it is processed by Altibase method. Okay, let's see how it works. Okay, so there's a memory table and a data 10 is inside the memory table as well. Okay. Okay, now the client is updating the data. So once the update is executed, the new version is created inside the table. Okay, and the old image is remaining, and then the new image is a change. Okay, not the old image. Okay, so the client has executed the select statement to see the data, and because the commit is not executed, it gets the original value, which is 10. And once the commit is executed, the value 20 is displayed, and the memory Asia deletes the old image. Okay, so in Altibase method, when creating a new image of record, the new image is created from the table where original record belongs to, and then it changes the value. Okay, the good thing about Altibase is the performance because the new image is not created in some random place, but in original place. Okay, however, in order to make new copy of record, another new page has to be used, so the memory usage could increase. Okay, so Altibase does not allow infinite number of copies to be created. That is, when a number of new images exceed the configured property, then it'll be automatically changed to in place mode. Okay, so it was about outplace method in memory table. Let's have a look at the in place, the MVCC for this table. Okay, the in place method. So for that this table does in place control, which is different to the memory table. And remember, outplace modify the new version record, but in place modify the original record from the original place. Okay, there's no new image of record created. So you might think, isn't it the same as SVCC? SVCC then? No, it's not. Okay, let's see how it differs. Okay, as you look at the diagram, there's this table with the data 10 inside, and you notice that there's something called undo area. Okay, there's undo area. Let's see what it is. Okay, so the client is updating a data, and once the update has been executed, the original data is stored into something called undo area, and the original data inside the table is changed to 20. Okay, the modification process is executed from the original record, but the original record is actually copied into undo area first. That's why it's not the same as SVCC, because there are two versions of records, not just one. Okay, so the client B selects the record and before it is committed. So client B does not have any authority, even though it can still access, so it actually selects from the undo area and where original record was copied into. Okay, now client A executed commit. So the client B now has the authority, so he gets a value of 20. And because it's committed, the original record saved in undo area is deleted and becomes useless. And when there's another modification, the undo area is reused. Okay, so this is how this table does the concurrency control. Okay, so we just talked about what is MVCC today. It's pretty much about today's topic. Okay, we talked about the types of log and how the log is managed in Altibase. We also talked about the types of concurrency control. Okay, in next session we're gonna talk about the buffer management. Okay, thanks for listening today, and I'll see you guys next time. Thank you.